In this video, we're going to look at reviewing adding and subtracting fractions. The key thing to remember when adding and subtracting fractions is that you must have the same denominator, and the golden rule is to add and subtract the numerators while keeping the denominator. Let's look at some examples. So let's look at a situation where they already have the same denominator. So for example, let's say we are looking at 2/5 plus 4/5. What we're going to do is basically add the numerator, add the top, while keeping the bottom the same. So as you notice, the denominator will always be 5. So when I add 2 plus 4, I get 6 over 5, which I can turn into a mixed number of 1 and 1/5. Let's look at a situation. Let's look at another situation. So this is the first example. A second example might be something like 4 and 1/5 minus 3 and 3/5. I don't know why I like fifths, but they all operate the same way. There's going to be two ways of going about handling this whole idea of mixed numbers. One is to go ahead and turn it into an improper fraction by doing 4 times 5 and get 20 and adding the 1. Becomes 21/5. And then I'm going to subtract. If I multiply 3 times 5, I get 15 plus 3 is 18/5. So then I think 21 minus 18, and then I'll divide by the 5, put it over the 5. So 21 minus 18 is 3. I'm left with 3/5. Okay. One thing to keep in mind, now that we've looked at integers, is that integers can apply to fractions as well. So let's take a situation where we're going to have 3/4 and I want to subtract 2 and 1/4. So if I use the process in B, I get 3/4 minus, if I do 2 times 4, I get 8, plus 1 is 9, so I have 9/4. So if I think 3 minus 9 over 4, 3 minus 9 is -6 over 4. So I keep the negative sign in front. 4 goes into 6 one time with 2 left over, so I have 2/4, which becomes -1 and 1/2. Okay, so this is all situations where I have the same denominator. A couple different examples and applications. Let's look what happens if they have different denominators. So if I have a situation like 7/8 and I want to subtract 5/9. I need to find what's called a common denominator. Okay. I find this helpful to set it up vertically a lot of times, but it's really your option of how to set it up. The reason being is because I can kind of do little arrows and go over. So I think of what is the least common multiple of 8 and 9. So a couple different ways I can do this. 8 times 9, if I multiply the denominators, I will always get a common multiple. It might not be the least. Another way of doing these is to list out 8, 16, 24, so all the multiples of 8. So it'd be 32, 40, 48, 56, 64, 72. And then do the same thing with 9. 9, 18, 27, 36, 45, 54, 63, 72. Sorry, that was 72. So 72 would be my least common multiple. It's the first number they both have in common. So that'll become my new denominator. So I have to think then, in order to get to 72, I would have to multiply 9 by 8. So whatever I do to the denominator, I also need to do to the numerator. 8 times 5 gives me 40. Okay. 8 times 9 gives me 72. So 7 times 9 gives me 63. The minus sign stays. 63 minus 40 gives me 23 over 72. And I need to look to see if I can reduce this. In this particular case, I can't, unless 72 is divided by 23, which it is not. So that becomes my final answer. Okay. So the key part when dealing with different denominators is to find an equivalent fraction, or find equivalent fractions with the same denominator. Okay. So once again, also to get to the 23, just to comment, you'll notice I basically did 63 minus 40 and then kept the 72 the same. The last segment I'd like to take a look at is showing you two methods of handling mixed numbers. There's going to be two ways of approaching this, and there's some pros and cons for both. One is easier for certain situations, while another is easier for other situations. So it's a good idea to know both strategies. Okay. The first we've already covered. What happens if I have 1 3/5 and I want to add 2 1/5? Okay, I can go ahead and change these into improper fractions. So 1 times 5 is 5, plus 3 is 8/5, plus this will be 11/5. So 8 plus 11 is 19 over 5. 5 goes into 19 3 times with a remainder of 4. So it's 3 4/5 will be my answer. This method of changing things to an improper fraction will basically always work without a problem. The other strategy for covering how to do this is if I begin with the 1 3/5, and I'm going to set it up vertically because it's a little bit easier to see. What I can do is add the fractions. 3/5 plus 1/5 gives me 4/5. 1 plus 2 is 3. Okay. I'm going to change one number on this, which will also change the answer a little bit. Okay. Instead of talking about 2 1/5, I'm going to change this to 2 4/5. So I'm creating a new problem out of this. If I add the fractions, I get 7/5, and 1 plus 2 is 3. This is still okay, but it's important to recognize in this mixed number, I have this improper fraction. 7/5 becomes 1 2/5. So I'm going to need to add that to 3. 3 plus 1 2/5 would equal 4 2/5 for an answer. Okay, which is okay. I would get the same answer if I changed it to an improper fraction. The other circumstance I would like to mention with this, besides possibly ending up with this improper fraction, deals particularly with subtraction. So let's pretend I had 4 1/5, and I wanted to subtract 3. Actually, let's do 2 4/5. What happens when I try to do 1/5 minus 4/5? There's two things that can happen. If I think 1 minus 4, I get negative 3/5. Then when I do 4 minus 2, I end up with positive 2. What this is basically thinking about asking, it's what happens when I have 2 and I want to decrease that by 3/5. Because remember, signs are important. So 1 minus 4, I can't get rid of that negative. 2 minus 3/5 would bring me down to 1 2/5. This will be my answer. Okay. The other way I can go about approaching this situation without possibly using this negative fraction within kind of this mixed number is if I think about it as 4 1/5, and if I subtract 2 4/5. If I realize I can't subtract, what I could also do is change the 4 1/5 I could borrow 5. So whatever the denominator is, I could borrow 5, which makes it 3 6/5. 5 plus 1 would give me the 6 in the numerator. And then I would keep this as 2 4/5. Okay. What I am doing here is basically what I'm doing up here in changing this improper fraction back to a mixed number and kind of breaking this apart. Okay, kind of breaking it apart. So here, what I'm basically doing, just to kind of break it out a little bit more, is instead of doing 4 1/5, I'm changing this to 3 plus 1 whole, which I'm saying is 5/5 plus 1/5. So I have 3 6/5 basically from that situation. If then I go to subtract, 6 minus 4 is 2/5. Okay, 6/5 minus 4/5 gives me 2/5. 3 minus 2 gives me 1. Okay, I end up with the same answer. These situations get a little bit messy. You can do it using either method, but particularly when things get complicated, like I just have demonstrated here and here, what I would suggest possibly doing is just changing it into an improper fraction. I would end up with 21/5 minus 14/5. 21 minus 14 gives me 7/5, which equals the 1 2/5. So while up here it might be quicker just to add using the mixed numbers, and as we saw in the first slide, it's pretty quick. In this particular situation, I might recommend just changing it to the improper fractions. It'll tend to be a little bit quicker that way. Anyway, hopefully this has been a helpful review, and look forward to practicing later.